Are you preparing for a MERNstack job interview and feeling overwhelmed with the amount of information out there? Don't worry, we've got you covered. In this video, we'll be sharing the top 50 MERNstack job interview questions and answers that you need to know for 2023. Whether you're a beginner or an experienced developer, this video will provide you with the knowledge and confidence you need to ace your next interview. Before we dive into the top 50 MERNstack job interview questions and answers, let's first take a look at what the MERNstack is all about. MERNstack is a popular full-stack JavaScript framework that consists of 4 key technologies: MongoDB, Express.js, React, and Node.js. MongoDB is a document-based NoSQL database that allows for flexible and scalable data storage. Expressjs is a web application framework that provides a set of robust features for building scalable and secure web applications. React is a JavaScript library that allows for building interactive user interfaces, while Node.js is a server-side runtime environment that allows for running JavaScript code outside of a web browser. When these technologies are combined, they provide a powerful and efficient platform for developing modern web applications. The MERNstack has gained widespread adoption due to its flexibility, scalability, and ease of use, making it a highly desirable skill set for employers looking for web developers. So, let's get started with the top 50 MERNstack job interview questions and answers. First question is, how does React work? Answer: React is a JavaScript library for building user interfaces that allows developers to create reusable UI components. When a React application is loaded in a web browser, it creates a virtual DOM, document object model, which is a lightweight representation of the actual DOM. When the state or props of a React component changes, React will re-render that component, which generates a new virtual DOM tree. React will then compare the new virtual DOM tree with the previous virtual DOM tree to determine which parts of the actual DOM need to be updated, added, or removed to reflect the changes. React makes use of a technique called reconciliation to efficiently update the DOM. This technique only updates the necessary parts of the DOM, which makes React applications fast and responsive. One of the key benefits of React is that it allows developers to create reusable components. React components are like building blocks that can be combined to create complex UIs. Developers can create their own custom components and reuse them throughout their application or share them with other developers. Another important feature of React is its ability to manage state. React components can have internal state, which allows developers to build interactive UIs that respond to user input. React also allows for the use of external state management libraries, such as Redux or MobX, to manage state across the entire application. Next question: what is props in React? Answer: in React, props is short for properties and refers to a mechanism for passing data between components. In a React component, props are a set of values that are passed down from a parent component to a child component. These values can be of any data type, including strings, numbers, objects, or even functions. Props are typically defined in the parent component and passed down to the child component as an attribute. For example, if we have a parent component called app and a child component called header, we could pass a prop called title to the header. Props are immutable, which means that they cannot be changed within the component that receives them. This helps to ensure that data is passed down in a predictable and controlled manner. However, props can be used to trigger changes in a component by passing down callback functions that are invoked in response to user actions. Next question is, what is replication in MongoDB? Answer is, in MongoDB, replication refers to the process of maintaining multiple copies of data across multiple servers, called a replica set. A replica set is a group of MongoDB servers that replicate data across multiple nodes, providing redundancy and fault tolerance. The replication process in MongoDB involves designating one node as the primary node, which accepts write operations and propagates changes to other secondary nodes in the replica set. Secondary nodes in the replica set replicate the data from the primary node and can serve read operations. If the primary node fails or becomes unavailable, one of the secondary nodes will be automatically promoted to the primary node, allowing the replica set to continue functioning without interruption. Once the original primary node is back online, it will rejoin the replica set as a secondary node and begin replicating data from the new primary node. Replication in MongoDB provides several benefits, including high availability. Replication ensures that data is available even in the event of a hardware or network failure. Scalability. By adding more secondary nodes to the replica set, you can increase read capacity and distribute the load across multiple nodes. Disaster recovery. Replication can be used to create a backup of data, which can be used for disaster recovery in the event of data loss or corruption. Geographic distribution. Replication can be used to maintain copies of data across multiple geographic locations, providing better performance and data locality for users in different regions. Alright, let's move further. Next question is, what are higher-order components? Answer. In React, a higher-order component, HOC, is a function that takes a component as input and returns a new component with additional functionality. Hooks are commonly used in React to abstract away common functionality that can be shared across multiple components. For example, if we have multiple components that need to fetch data from an API and display it in the UI, we can create an HOC that handles the data fetching and pass it to each of the components as a higher-order component. Next question, what do you mean by asynchronous API? Answer. In computing, an asynchronous API, application programming interface, is a type of API that allows a program to execute multiple tasks concurrently without blocking the execution of the main program. In other words, an asynchronous API allows a program to continue running while it waits for a response from an external service or resource. In contrast to a synchronous API, which blocks the execution of a program until a response is received, an asynchronous API provides a way for a program to submit a request and continue executing other tasks until a response is received. Asynchronous APIs are commonly used in web development to communicate with external services, such as databases, web servers, or other web applications. For example, an application might use an asynchronous API to fetch data from a remote server or to upload a file to a cloud storage service. Asynchronous APIs are typically implemented using callbacks, promises, or async/await syntax in JavaScript. These mechanisms allow a program to submit a request and register a callback function that will be called when a response is received, or to wait for a promise to resolve with a response. The use of asynchronous APIs is particularly important in web development, where network latency and other factors can cause delays in the processing of requests. By using asynchronous APIs, programs can continue executing while waiting for a response, improving performance and user experience. Alright. Next question, what is callback hell? Answer is callback hell is a term used to describe the situation that can arise when using asynchronous callbacks in JavaScript code, where the code becomes difficult to read and maintain due to nested callbacks. This can occur when multiple asynchronous operations need to be performed one after the other, and the result of each operation depends on the result of the previous one. Next question, what is reconciliation? Answer is reconciliation is a process in React that updates the user interface based on changes in the application state. When a component state or props change, React will initiate the reconciliation process to determine which parts of the UI need to be updated. During the reconciliation process, React compares the previous version of the component tree with the new version and identifies the differences between them. It then applies the necessary updates to the DOM to reflect the changes in the UI. Reconciliation is an important feature of React because it allows developers to update the UI efficiently without having to manually modify the DOM. By minimizing the number of changes that need to be made, React can reduce the amount of work required to update the UI, resulting in better performance and a smoother user experience. React uses a virtual DOM, a lightweight copy of the actual DOM, to perform the reconciliation process. By making changes to the virtual DOM instead of the actual DOM, React can perform updates more efficiently and avoid unnecessary re-renders. Next question is, does MongoDB support foreign key constraints? Answer is MongoDB does not support foreign key constraints in the same way that traditional relational databases do. In a traditional relational database, a foreign key constraint is used to enforce referential integrity between tables, ensuring that a value in one table corresponds to a value in another table. In MongoDB, data is stored in collections of documents rather than tables, and relationships between documents are typically represented using embedded documents or references. While MongoDB supports the use of references to represent relationships between documents, it does not enforce referential integrity between collections. However, MongoDB does provide some features that can be used to implement similar functionality to foreign key constraints. For example, MongoDB supports the use of the $lookup aggregation pipeline stage to perform a join between two collections, allowing documents from one collection to be matched with documents from another collection based on a common field. Additionally, MongoDB provides support for the use of schema validation rules to enforce constraints on the structure and content of documents within a collection. While this does not provide the same level of referential integrity as foreign key constraints in a traditional relational database, it can help to ensure that data is consistent and valid within a collection. Next question is how Node prevents blocking code? Answer: Node.js is designed to be non-blocking, which means that it is able to handle large amounts of input and output (I/O) operations without blocking the execution of other parts of the application. This is achieved through the use of an event-driven, asynchronous model. In the event-driven model, Node.js relies on an event loop to manage the execution of asynchronous callbacks. When an asynchronous I/O operation is initiated, Node.js registers a callback function to be executed when the operation is complete. This allows Node.js to move on to other parts of the application, rather than waiting for the I/O operation to complete. When the I/O operation is complete, Node.js adds the callback to a queue, which is processed by the event loop. The event loop continuously checks the queue for new callbacks to execute, and runs them in the order that they were added. This allows multiple I/O operations to be executed simultaneously, without blocking the execution of other parts of the application. Additionally, Node.js provides a number of built-in modules that are designed to be non-blocking, such as the HTTP and HTTPS modules. These modules use the event-driven model to handle incoming requests and responses without blocking the execution of other parts of the application. Next question: how can you achieve transaction and locking in MongoDB? Answer: MongoDB supports multi-document transactions in versions 4.0 and higher. Transactions allow developers to group operations together and ensure that they are either all completed successfully or rolled back if an error occurs. In order to use transactions in MongoDB, the database must be running in a replica set or a sharded cluster. Transactions are performed using the start transaction and commit transaction or abort transaction methods, which are available in the MongoDB drivers for different programming languages. MongoDB also provides support for locking through the use of document-level locking. In MongoDB, each document is locked during a write operation to ensure that only one write operation can modify the document at a time. This allows MongoDB to ensure data consistency and prevent conflicts between concurrent write operations. Additionally, MongoDB provides support for client-side locking through the use of the findAndModify method. This method allows developers to atomically update a document and return its updated value, while also locking the document to prevent other write operations from modifying it at the same time. Next question is, how does Node.js handle child threads? Answer is in Node.js, child threads are implemented using the child_process module. This module provides the fork method, which creates a new Node.js process that runs the same JavaScript code as the parent process. The child process can communicate with the parent process through interprocess communication (IPC) channels. This allows the parent and child processes to exchange data and coordinate their activities. The child_process module also provides methods for managing child processes, such as spawn, exec, and execfile. These methods allow you to start a new process and communicate with it through streams, callbacks, and events. In general, Node.js uses a thread pool to manage asynchronous I/O operations. This means that the main event loop of the Node.js process runs on a single thread, and all I/O operations are delegated to a pool of threads. When a child process is created, it is run on a separate thread from the main event loop. This allows the child process to perform long-running operations without blocking the main event loop. Overall, Node.js provides a flexible and powerful mechanism for creating and managing child threads, allowing developers to take advantage of multiple CPUs and achieve better performance and scalability in their applications. Let's move further, guys. Next question is, how to avoid callback hell in Node.js? Answer is: callback hell is a common problem that arises when working with asynchronous operations in Node.js. It occurs when there are nested callbacks that are difficult to read, debug, and maintain. Fortunately, there are several techniques that can be used to avoid this problem. Use promises. Promises provide a cleaner way to handle asynchronous operations. They allow you to chain multiple asynchronous operations together and handle errors in a more structured way. Promises can be used with built-in Node.js modules or with third-party libraries. Use async/await. Async/await is a more recent addition to Node.js and provides a way to write asynchronous code that looks more like synchronous code. This can make your code easier to read and understand, and can also reduce the likelihood of errors. Use control flow libraries. There are several control flow libraries available for Node.js that provide a more structured way to handle asynchronous operations. Popular examples include async.js, Q, and Bluebird. These libraries provide a way to avoid callback hell by managing the flow of asynchronous operations in a more organized way. Modularize your code. Splitting your code into modules can help reduce the complexity of your code and make it more modular. By breaking your code into smaller, more manageable pieces, you can reduce the amount of nesting required and make your code easier to understand and maintain. Use error handling middleware. Middleware can help you handle errors in a more structured way. Middleware can be used to catch errors and provide a consistent way to handle them across your application. By using these techniques, you can avoid callback hell and write asynchronous code that is easier to read, maintain, and debug. Okay. Next question is, if Node.js is single-threaded, then how it handles concurrency? Answer: although Node.js is a single-threaded environment, it is capable of handling concurrency through several mechanisms. Event loop. The event loop is the heart of Node.js, and it is responsible for handling I/O operations asynchronously. When a request comes in, Node.js registers a callback function and continues processing other requests. When the I/O operation is complete, the callback function is executed. This mechanism allows Node.js to handle multiple requests concurrently. Non-blocking I/O. Node.js uses non-blocking I/O to handle requests. This means that when a request is made, the thread does not wait for the response. Instead, it moves on to the next request. This allows Node.js to handle multiple requests simultaneously without blocking. Child processes. Node.js allows developers to create child processes that can run in parallel with the main thread. This means that you can spawn multiple child processes to handle requests concurrently. Clustering. Node.js provides a built-in module called cluster that allows you to create a cluster of Node.js processes that can handle requests in parallel. The cluster module allows you to create multiple instances of your application and distribute requests across them. This can help you take advantage of multiple CPU cores and improve the performance of your application. Overall, Node.js uses several mechanisms to handle concurrency, even though it is a single-threaded environment. These mechanisms allow Node.js to handle multiple requests simultaneously and improve the performance and scalability of your applications. Alright. Next question: what are pure components? Answer is pure components are a concept in React, a JavaScript library for building user interfaces. A pure component is a React component that does not depend on any external state or side effects. It receives its data through props and renders the same output for the same set of props. Pure components are designed to be highly performant because they can be memoized by React. When a pure component receives the same props as the previous render, React can skip the rendering process altogether and reuse the existing output. This can help reduce the number of unnecessary renders and improve the overall performance of your application. Pure components can be created using the React.pureComponentBase class. When you extend React.pureComponent, React automatically implements the shouldComponentUpdate method, which compares the previous props and state with the current props and state. If they are the same, React will skip the rendering process and reuse the existing output. Let's jump to the next slide. Next question is: what are React hooks? Answer: hooks provide a way to reuse stateful logic across components, simplify complex components, and make them more functional. There are several built-in hooks available in React. UseStateHook, it allows you to add state to functional components. UseEffectHook, it allows you to perform side effects, such as fetching data, updating the DOM, or subscribing to events. UseContextHook, it allows you to access context in functional components. UseReducerHook, it allows you to use a reducer with local state in functional components. UseCallbackHook, it allows you to memoize functions in functional components. UseMemoHook, it allows you to memoize values in functional components. UseRefHook, it allows you to create a mutable reference in functional components. UseLayoutEffectHook, it's similar to UseEffectHook, but runs synchronously after all DOM mutations. React hooks provide a way to manage stateful logic in functional components without the need for class components or higher-order components. This can simplify your code and make it easier to read and maintain. Additionally, React hooks encourage a more functional programming style, which can lead to more modular and reusable code. Okay. Next question is: what is aggregation in MongoDB? Answer: aggregation in MongoDB is the process of performing data processing operations on collections of documents. It allows you to filter, group, sort, transform, and analyze data in a flexible and powerful way. Aggregation is typically used to summarize or aggregate data and present it in a useful format for analysis or reporting. Aggregation in MongoDB is performed using the aggregation pipeline, which is a framework for processing documents in a series of stages. Each stage performs a specific data processing operation on the input documents and passes the results to the next stage. The aggregation pipeline can include multiple stages, each of which can be used to perform a different operation. Some common aggregation pipeline stages include $match, it's used for filters documents based on a specified condition. $group, it's used for groups documents based on a specified key and performs calculations on the grouped data. $project, it's used to select a subset of fields from the input documents and optionally apply transformations to them. $sort, it's used for sorting the input documents based on a specified field or fields. $limit, it's used to limit the number of documents in the output. $skip, it's used to skip a specified number of documents in the input. Aggregation in MongoDB is a powerful and flexible tool for data processing and analysis. It allows you to perform complex data transformations and analysis on large collections of documents in a fast and efficient way. Next question is, what is JSX? Answer: JSX is a syntax extension for JavaScript that allows you to write HTML-like code inside your JavaScript code. JSX was developed by Facebook as part of the React library for building user interfaces. JSX allows you to describe how your user interface should look in a declarative way, making it easier to reason about and maintain. JSX is not a template language, but a syntax extension that allows you to embed HTML-like code in your JavaScript code. JSX is transformed into regular JavaScript code using a transpiler, like Babel. The resulting JavaScript code is then executed in the browser or on the server using Node.js. Next question is 18 Quetzales, what is React.DOM? Answer: React.DOM is a library that provides an interface for rendering React components to the DOM, document object model, or to a string. It's a separate library that is typically used alongside the main React library. When you write a React component, you're defining a component's behavior and structure. However, in order for that component to actually be displayed on a web page, it needs to be rendered to the DOM. React.DOM provides the methods for rendering your components to the DOM. Alright. Next question, what is sharding in MongoDB? Answer is sharding in MongoDB is a method for horizontally scaling a database across multiple servers, or shards. Sharding allows you to distribute your data across multiple servers, which can improve performance and increase the amount of data that your database can handle. In a sharded MongoDB cluster, each shard is a separate database that contains a subset of the overall data. The shards are distributed across multiple servers, called shard servers or nodes, which work together to handle queries and updates to the data. The sharding process is controlled by a shard key, which is a field or combination of fields in your documents that determines which shard a document belongs to. MongoDB automatically routes queries to the appropriate shard based on the shard key. Sharding in MongoDB involves several components, including config servers. These servers store metadata about the sharded cluster, such as the shard key range and the location of each shard. Shard servers. These servers store the actual data, divided into chunks based on the shard key range. Query routers. These servers receive incoming queries and route them to the appropriate shard based on the shard key. Sharding in MongoDB provides several benefits, including horizontal scaling. Sharding allows you to distribute your data across multiple servers, which can improve performance and increase the amount of data that your database can handle. Automatic load balancing. MongoDB automatically distributes data evenly across the shards and balances the load between them. High availability. Sharding provides automatic failover and replication, ensuring that your data is always available and up to date. Alright, next question is, what is stream and what are types of streams available in Node.js? Answer: data that can be read from or written to. Streams are used to handle large amounts of data in a memory-efficient and performant way, by processing data in small chunks rather than loading the entire dataset into memory. There are 4 types of streams in Node.js. Readable streams. These streams are used for reading data from a source, such as a file, network socket, or HTTP request. Readable streams can be read in a variety of ways, including using the data event, the read method, or by piping them to a writable stream. Writable streams. These streams are used for writing data to a destination, such as a file, network socket, or HTTP response. Writable streams can be written to using the write method or by piping data from a readable stream. Duplex streams. These streams are both readable and writable, allowing for bidirectional communication between the source and destination. Duplex streams can be created by combining a readable and writable stream using the duplex class. Transform streams. These streams are a type of duplex stream that can modify or transform data as it passes through the stream. Transform streams can be created by extending the transform class and implementing the _transform and _flush methods. Streams in Node.js provide several benefits, including memory efficiency. Streams allow you to process large amounts of data without loading the entire dataset into memory. Performance. Streams can process data in small chunks, allowing for faster processing and reduced latency. Modularity. Streams can be combined and piped together to create complex data processing pipelines. Next question: what is prop drilling? Answer is prop drilling is a term used in React to describe the process of passing data from a parent component to a child component through several layers of intermediate components, even when those intermediate components don't need the data themselves. This can result in cluttered and verbose code, as well as performance issues if the data being passed is large or complex. Prop drilling can occur when a component needs to pass data down to its children, but that data is not directly available to the children. In this case, the parent component will pass the data down through its own props, and each intermediate component will pass the data down through its own props as well, until it reaches the final child component that needs the data. Prop drilling can be avoided by using other techniques such as context, Redux, or other state management libraries. Context is a built-in React feature that allows you to pass data down through a tree of components without the need for prop drilling. Redux is a popular state management library that allows you to store and manage application state in a central location, making it easier to access and share data between components. Next question: what is key? Answer is in React. A key is a special attribute that is used to uniquely identify a component in a list of siblings. When rendering a list of components using a loop, each component must have a key attribute set, which helps React to efficiently update and re-render only the components that have changed, rather than re-rendering the entire list. The key attribute is a string that should be unique among the components in the list, and should be stable across re-renders. React uses the key attribute to identify the component and its corresponding DOM element, and can quickly compare the old and new versions of the list to determine which components need to be updated or re-rendered. If a key attribute is not set or is not unique, React may experience performance issues or unexpected behavior, such as components being reordered or duplicated. Next question is: what is a blocking code? Answer is, in Node.js, blocking code refers to code that runs synchronously and blocks the event loop from processing additional events until the blocking operation is complete. This means that while a blocking operation is running, Node.js cannot respond to any other requests or events, including new HTTP requests or incoming data on a network socket. Blocking code is typically caused by long-running or CPU-intensive operations, such as file I/O, database queries, or complex calculations. When a blocking operation is encountered in Node.js, the entire program will pause and wait for the operation to complete before continuing with the next task. Blocking code can have negative impacts on the performance and scalability of a Node.js application. In particular, blocking operations can cause the event loop to become backed up and unresponsive, leading to increased latency and reduced throughput. To avoid blocking code in Node.js, it is recommended to use asynchronous, non-blocking operations wherever possible. This can be achieved using features such as callbacks, promises, or async/await, which allow code to continue running while the operation is being performed in the background. Alright. Let's discuss next one. Question is, what is the difference between Shadow DOM and Virtual DOM? Answer: Shadow DOM and Virtual DOM are two distinct concepts in web development, with different purposes and use cases. Shadow DOM is a browser feature that allows for encapsulation of a web component's HTML, CSS, and JavaScript. It enables developers to create isolated DOM subtrees within a larger document, with their own styles and behavior that are not affected by the styles or behavior of the surrounding document. Shadow DOM can be used to create reusable and encapsulated web components that can be easily integrated into any web page. Virtual DOM, on the other hand, is a concept used in front-end frameworks like React that helps to optimize the updating and rendering of the user interface. It is a lightweight representation of the actual DOM that React uses to compare the current state of the UI with the desired state. When changes are made to the UI, React updates the virtual DOM and compares it with the previous version to determine the minimum number of changes needed to update the actual DOM. This approach improves performance by reducing the amount of time and resources required to update the UI. In summary, Shadow DOM and Virtual DOM are two distinct concepts with different purposes. Shadow DOM enables encapsulation of a web component's HTML, CSS, and JavaScript, while Virtual DOM helps to optimize the updating and rendering of the UI in front-end frameworks like React. Okay. Next question, what's the event loop? Answer: The event loop is a fundamental concept in Node.js that enables the runtime to handle I/O operations and asynchronous events efficiently. Node.js is built on the principle of non-blocking I/O, which means that it can execute multiple operations simultaneously without waiting for one to finish before moving on to the next. When an I/O operation is started, Node.js will move on to execute other code while the operation is being processed in the background. Once the operation is complete, Node.js will then notify the application and execute a callback function to handle the results. The event loop is responsible for managing these asynchronous operations and callbacks. It is a continuous loop that checks for new events in the event queue and executes their associated callback functions. When a new event is added to the queue, it is processed in the next tick of the event loop. The event loop consists of several phases, each with its own queue of events. The phases include timers, pending callbacks, idle, pull, and check. Each phase has its own set of tasks and operations to execute, and the event loop moves between the phases in a specific order. Understanding the event loop is critical for writing efficient and scalable Node.js applications, as it enables developers to write code that takes advantage of the non-blocking I/O model and avoids blocking operations that can cause performance issues. Next question, what's the difference between a smart component and a dumb component? Answer: In the context of React, a smart component is also referred to as a container component or a stateful component, while a dumb component is also referred to as a presentational component or a stateless component. The difference between the two lies in their responsibilities and how they manage data. A smart component is responsible for managing state and handling data logic. It often contains business logic, data fetching, and data manipulation code. Smart components are typically connected to the Redux store or other data sources and pass down data as props to their child components. On the other hand, a dumb component is responsible for presenting data and rendering UI elements. It receives data as props from its parent components and uses that data to render the UI. Dumb components don't manage state, don't perform data fetching or manipulation, and don't interact with the Redux store or other data sources. The main advantage of separating components into smart and dumb components is that it makes the code easier to maintain and test. Smart components can be reused throughout the application and can be easily connected to different data sources or Redux stores. Dumb components are also reusable and can be easily tested, as they don't contain complex business logic or state management code. Okay, let's discuss next question. Next question, what is Mongoose? Answer, Mongoose is a popular object document mapping (ODM) library for MongoDB and Node.js. It provides a simple, yet powerful way to interact with MongoDB databases by providing a schema-based solution for modeling application data. With Mongoose, developers can define their data schema, create models, and interact with MongoDB databases using a high-level API. It provides a number of features including schema validation, middleware, query building, data aggregation, and much more. Mongoose also simplifies data relationships by providing support for embedded documents and referencing documents in other collections. It also has built-in support for promises and callbacks, allowing developers to work with the API in the way they prefer. Next question, what is REPL in Node.js? Answer, REPL stands for React Loop. It is a built-in feature of Node.js that allows developers to interactively run JavaScript code in the terminal. REPL provides an environment for developers to quickly prototype and test out code snippets without having to write a full script or application. It can be useful for debugging, testing, and exploring different aspects of the Node.js runtime and JavaScript language. When you launch the Node.js interpreter in the terminal by typing Node, you will be able to enter code directly into the terminal, and REPL will evaluate and execute it immediately. The result will be printed in the console, and you can then enter new code to execute. In addition to running JavaScript code, REPL also provides some additional features like tab completion, syntax highlighting, and multiline input. These features can make it easier and more efficient to work with the REPL environment. Next question, how to check if an object is an array or not in JavaScript? Answer is in JavaScript, there are a couple of ways to check if an object is an array or not. Using the array.isArray method. The most straightforward way to check if an object is an array or not is to use the array.isArray method. This method returns true if the passed argument is an array and false otherwise. Next is using the instanceif operator. Another way to check if an object is an array or not is to use the instanceif operator. The instanceif operator checks whether an object is an instance of a particular class. Since arrays are instances of the array class, we can use the instanceif operator to check if an object is an array or not. Both of these methods are reliable and commonly used in JavaScript to check if an object is an array or not. Alright. Next question is list down the two arguments that async queue takes as input in Node.js. Answer, the async queue function is a powerful function provided by the async.js library in Node.js that enables asynchronous processing of tasks in a queue. It takes the following two arguments. Worker function, this is the function that is called for each task in the queue. The worker function takes two arguments, the task that is being processed and a callback function that needs to be called once the task is complete. Concurrency, this argument specifies the maximum number of tasks that can be processed concurrently. It represents the maximum number of workers that can be running at the same time. If the number of tasks in the queue exceeds the concurrency limit, the remaining tasks will be queued and executed as soon as a worker becomes available. Alright, let's jump on the next slide. Next question is, what is the purpose of module.exports in Node.js? Answer, in Node.js, the module.exports object is used to define what a module exports and makes available for other modules to use. Every Node.js file is considered a module, and each module can have its own module.exports object. By default, the module.exports object is an empty object. However, you can assign a value, function, or object to it, which can be accessed by other modules that require it. Next question, what is Node.js streams? Answer, in Node.js, streams are a powerful and efficient way of handling data flow between different parts of an application. Streams are a type of object that allows you to read or write data in chunks, rather than reading or writing it all at once. Streams can be used to read data from files, network sockets, HTTP responses, or any other source that produces a continuous flow of data. Similarly, streams can be used to write data to files, network sockets, HTTP requests, or any other destination that accepts a continuous flow of data. Streams in Node.js are based on the event emitter class, which means they emit events when data is available to be read, when the stream is closed, or when an error occurs. This event-driven model allows you to handle data as it becomes available, rather than waiting for the entire data to be loaded into memory. Node.js provides 4 types of streams. Readable streams, it's used for reading data from a source. Writable streams, it's used for writing data to a destination. Duplex streams, it's used for both reading and writing data. Transform streams, it's used for modifying or transforming data as it flows through the stream. By using streams, you can process large amounts of data efficiently, with low memory usage, as it allows you to work with data in small chunks. Streams also provide a way to handle data asynchronously, allowing you to perform other tasks while data is being read or written in the background. Next question is, what are Node.js buffers? Answer: in Node.js, a buffer is a temporary storage area for data while it is being moved from one place to another. Buffers are used to represent binary data in a format that can be manipulated using JavaScript. Buffers are essentially arrays of integers, where each integer represents a byte of data. Since Node.js is built on top of the V8 JavaScript engine, which only supports handling text data, buffers are used to handle binary data like images, videos, and audio files. Buffers in Node.js are implemented using the buffer class, which provides a way to create and manipulate binary data. Buffers can be created in several ways, including by specifying the size of the buffer, by passing an array of integers, or by encoding a string into binary format. Next question is, explain the concept of stub in Node.js. Answer: in Node.js, a stub is a function that mimics the behavior of a real function, but provides predefined output values. Stubs are often used in testing to isolate a function or module from its dependencies, so that the test can focus on the behavior of the function being tested. A stub can be created using a testing framework like Mocha, or by manually creating a function that returns a predefined value. When a stub is called, instead of executing the real code, it returns the predefined value, allowing the test to proceed without requiring the actual functionality. Alright, next question is, what is a thread pool and which library handles it in Node.js? Answer is, a thread pool is a collection of worker threads that are managed by the operating system or a library, and can be used to execute tasks concurrently. In Node.js, the worker_threads module is used to create and manage a thread pool, allowing you to perform CPU-intensive tasks without blocking the main event loop. The worker_threads module was introduced in Node.js version 10, and provides a way to create worker threads that can run JavaScript code in parallel. By using worker threads, you can take advantage of multiple CPU cores and perform tasks more efficiently. When you create a worker thread in Node.js, it is added to the thread pool and can be used to execute tasks in parallel with the main event loop. The thread pool is managed by the lib library, which is part of the Node.js core, and provides a platform-independent API for working with threads. Let's move further. Next question is, how to make Node modules available externally. Answer: to make a Node.js module available externally, you can publish it to a package manager like npm, Node Package Manager, or Yarn. Once published, others can install and use your module in their own Node.js projects. Here are the steps to publish a Node.js module to npm. Create a package.json file in your project directory by running the command npm init and following the prompts. This file contains metadata about your module, such as its name, version, description, and dependencies. Write the code for your module, and make sure to export any functions, classes, or variables that should be accessible to other modules. Once your module is ready, create an account on the npm website if you don't already have one. Run the command npm login in your terminal and enter your npm credentials to authenticate with the registry. Run the command npm publish to publish your module to the npm registry. Once published, other developers can install your module by running the command npm install your module name in their own Node.js projects. They can then require your module in their code and use its exported functions, classes, or variables. Note that when publishing a module to npm, it's important to follow best practices for versioning, documentation, and testing to ensure the quality and reliability of your module. Next question: what is the default scope of Node.js application? Answer is in Node.js. The default scope of an application is the module scope. In other words, every module in Node.js has its own scope, and any variables or functions defined in one module are not automatically accessible in another module. This means that in order for one module to use the functionality of another module, it needs to explicitly import or require that module using the require function. This also means that any variables or functions defined within a module are not accessible outside of that module, unless they are explicitly exported using the module.exports or exports objects. However, it's worth noting that Node.js provides several ways to share functionality between modules, such as global variables or singletons, but these methods should be used with caution to avoid introducing unexpected behavior or coupling between modules. Next question is, which module is used to serve static files in Node.js? Answer is in Node.js. The built-in FS file system module can be used to serve static files by reading files from the file system and sending them as responses to HTTP requests. However, using the FS module to serve static files can be inefficient, especially for large files or high-traffic websites. To serve static files more efficiently in Node.js, the Express module is commonly used. Express provides a middleware called Expressstack that can be used to serve static files such as images, CSS, and JavaScript files. Next question is, what is a document in MongoDB? Answer in MongoDB, a document is the basic unit of data storage, and it is roughly equivalent to a row in a relational database table. A document is a JSON-style object that contains key-value pairs, where the keys are strings and the values can be various data types, such as strings, numbers, Boolean values, arrays, and other nested documents. Documents in MongoDB are stored in collections, which are roughly equivalent to tables in a relational database. Each document in a collection can have a different structure, and the schema can be flexible and evolve over time as new fields are added or removed. Next question, what is the Mongo shell? Answer is the Mongo shell is a command-line interface for interacting with MongoDB. It provides a way to connect to a MongoDB instance, query, and manipulate data, and perform administrative tasks using a JavaScript-based interface. The Mongo shell is based on the SpiderMonkey JavaScript engine, and it allows you to execute JavaScript code directly against the database, using a set of predefined functions and operators. You can use the Mongo shell to perform a variety of tasks, such as creating and deleting databases, inserting and updating data, and querying data using a variety of operators and methods. Next question, how do you delete a document in MongoDB? Answer is the CRUD API in MongoDB provides delete one and delete many for this purpose. Both of these methods take a filter document as their first parameter. The filter specifies a set of criteria to match against in removing documents. Alright, let's move further. Next question is explain the process of sharding. Answer. Sharding is a method of horizontally scaling a database by partitioning data across multiple machines or nodes in a cluster. It involves breaking up a large database into smaller, more manageable pieces called shards. The process of sharding typically involves the following steps. Planning and preparation. Before sharding, it's important to carefully plan and prepare for the process. This involves determining the optimal shard key, which is the field or set of fields used to distribute data across the shards. It's also important to consider the performance requirements and availability of the system. Creating a shard cluster. A shard cluster is a set of nodes that work together to store and manage the shards. This involves setting up multiple servers or virtual machines that will host the shards. Enabling sharding. Once the cluster is set up, sharding must be enabled in the database. This involves running a command to enable sharding on a particular database. Creating sharded collections. Sharded collections are collections that are partitioned across multiple shards. To create a sharded collection, you must specify a shard key that determines how data is distributed across the shards. Adding shards. Once the sharded collections are created, you can add shards to the cluster as needed. This involves adding new servers or virtual machines to the cluster and configuring them to host shards. Balancing data. As data is added to the system, it's important to balance the data across the shards to ensure that no single shard becomes overloaded. MongoDB provides an automatic balancing mechanism that redistributes data across the shards based on usage patterns. Monitoring and maintenance. Sharding requires ongoing monitoring and maintenance to ensure that the system is performing optimally. This includes monitoring the status of the shards, identifying and resolving any issues, and optimizing performance as needed. Alright, next question is, what is a replica set in MongoDB? Answer: a replica set in MongoDB is a group of MongoDB servers that replicate data to provide high availability and fault tolerance. It consists of multiple MongoDB nodes, with one node being the primary node that receives all write operations and the remaining nodes being secondary nodes that replicate data from the primary node. Replica sets provide several benefits, including high availability. In a replica set, if the primary node fails, one of the secondary nodes is automatically promoted to become the new primary node, ensuring that the database remains available. Fault tolerance. A replica set provides fault tolerance by ensuring that data is replicated to multiple nodes. If one node fails, data can be retrieved from another node in the replica set. Scalability. Replica sets can be used to scale read operations by directing them to secondary nodes, which can handle read operations while the primary node handles write operations. Durability. By replicating data to multiple nodes, a replica set provides durability by ensuring that data is not lost in the event of a node failure. To create a replica set in MongoDB, you must first set up multiple nodes with identical data. One node is then designated as the primary node, and the remaining nodes are designated as secondary nodes. The primary node receives all write operations, while the secondary nodes replicate data from the primary node. Replica sets use a consensus algorithm called replica set protocol to elect a new primary node if the current primary node fails. This process ensures that the replica set remains highly available and fault tolerant. Next question: what is scaffolding in Express.js? Answer: scaffolding in Express.js is the process of generating boilerplate code and directory structure for an application. It provides a starting point for building a new application by creating pre-built code and directories for common application features such as models, views, and controllers. Express.js scaffolding provides a way to quickly create a basic application structure that can be easily modified and extended to fit specific needs. This can save time and effort when starting a new project, as developers don't have to write all the code from scratch. Express.js scaffolding can be done using various tools and generators, such as the Express generator. The Express generator is a command line tool that generates a basic application structure with commonly used features such as middleware, routes, and templates. Using the Express generator, developers can create a new application by running a single command that generates the basic structure for the application. The generated structure includes directories for models, views, controllers, and public assets, as well as pre-built code for handling HTTP requests and responses. The scaffolding process provides a foundation for building a new application and can be customized to fit specific requirements. It's important to note that while scaffolding can be a useful starting point, it's essential to understand the code that is generated and modify it as needed to ensure that the application meets specific requirements. Next question is, what is routing and how routing works in Express.js? Answer is routing in Express.js refers to the process of matching incoming HTTP requests with the appropriate controller functions that handle those requests. In other words, routing determines how an Express.js application responds to a client request to a specific endpoint or URL. When a client sends an HTTP request to an Express.js application, the application's routing system matches the request to a route based on the URL and HTTP method, GET, POST, etc. The route is defined by a combination of a path and an HTTP method, which together are referred to as a route handler. The route handler is a function that is executed when a request to the specified route is received. The route handler can perform various actions such as querying a database, returning a static file, or rendering a view. Next question: what is middleware in Express.js? Answer: middleware in Express.js refers to functions that are executed in a pipeline during the processing of an HTTP request. Middleware functions have access to the request and response objects, and can modify or augment them as needed. In Express.js, middleware functions can be used for a variety of purposes, such as logging, authentication, error handling, and more. Middleware functions can be defined at the application level or at the root level, and can be executed in a specific order or conditionally based on certain criteria. There are three types of middleware in Express.js. Application-level middleware. This type of middleware is applied to the entire Express.js application and can be used for tasks such as setting up environment variables, parsing request bodies, and more. Application-level middleware can be defined using the appUse method. Root-level middleware. This type of middleware is applied to specific routes in the Express.js application and can be used for tasks such as authentication, authorization, and more. Root-level middleware can be defined using the same appUse method or using methods such as appget, apppost, and so on. Error handling middleware. This type of middleware is used to handle errors that occur during the processing of an HTTP request. Error handling middleware must be defined after all other middleware functions and routes. Error handling middleware functions have 4 parameters: error, req, res, and next. Alright. Let's move further. Next question is, what function arguments are available to Express.js root handlers? Answer: Express.js root handlers have access to 3 main function arguments: request, response, and next. Request. This argument represents the HTTP request made by the client and contains information about the request, such as the request method, URL, headers, and parameters. The request object is commonly abbreviated as REQ. Response. This argument represents the HTTP response to be sent back to the client and contains methods and properties for setting the response headers, status code, and body. The response object is commonly abbreviated as res. Next, this argument is a callback function that can be used to pass control to the next middleware or root handler in the pipeline. If next is not called, the request will be left hanging and the client will not receive a response. The next function can also be used to handle errors in middleware and root handlers. Next question is, how can I authenticate users in Express? Answer is, authentication is another opinionated area that Express does not venture into. You may use any authentication scheme you wish. There are many ways to authenticate users in an Express.js application, but one common method is to use a middleware function to verify user credentials and set a session or token to indicate that the user is authenticated. The next question is, which template engines does Express support? Answer is, Express supports a variety of template engines for rendering dynamic HTML views, including Pug, formerly known as Jade, a template engine that uses indentation and tags to create HTML templates. EJS, embedded JavaScript, a template engine that uses JavaScript code embedded within HTML templates. Handlebars, a template engine that uses curly braces to create HTML templates with dynamic data. Mustache, a template engine that uses a syntax similar to Handlebars and supports logicless templates. React, a JavaScript library for building user interfaces that can also be used as a template engine with Express. Twig, a template engine for PHP that can be used with Express using the twig.js module. Nunjux, a template engine inspired by Jinja 2 that supports template inheritance, macros, and filters. Alright, dear learners, last question of the session is, how do I render plain HTML in Express? Answer: there's no need to render HTML with the res.render function. If you have a specific file, use the res.sendFile function. If you are serving many assets from a directory, use the ExpressStatic middleware function. Thank you guys for listening to me with patience. In conclusion, the MERN Stack, MongoDB, Expressjs, React, and Node.js is a popular technology stack for building full-stack web applications. If you're preparing for a job interview for a MERN Stack developer role, it's important to have a good understanding of the various components of the stack and how they work together. We've covered the top 50 MERN Stack interview questions and answers that you're likely to encounter in a job interview. These questions cover a wide range of topics, including database design, server-side programming, front-end development, and deployment. To summarize, some of the key concepts and skills that you'll need to master for a MERN Stack developer role include designing and querying databases using MongoDB, building RESTful APIs using Express.js, developing scalable and maintainable web applications using React, writing server-side code using Node.js, using version control systems like Git, deploying and managing web applications on cloud platforms like AWS or Heroku. By understanding these concepts and practicing your coding skills, you'll be well prepared for any MERN Stack job interview that comes your way. Good luck!